This video will continue looking at Chapter 10, Triangle Trigonometry, and Section 10.1, Angles and Right Triangles. So we're going to specifically be looking at special right triangles in this video. And so in some of the rules, really want you to pay attention to and write down these rules. They will help you in the future of being able to try to solve these. And it's going to be my goal to break down some of the misunderstanding or that might be accompanied with being able to use some of these. I remember going through high school and doing some of these problems originally, and it just seemed like it was just really difficult to understand because the teacher didn't tell me up front, well, here's the ways to be able to get some help on these rather than trying to figure it out on my own. So I want to try to help if anybody else had a teacher like mine, and I'm going to tell you up front what the rules are and then see if that makes it easier to solve the problems. So the special triangles that we're talking about are going to be these right triangles, and I really encourage you to write these down in your notes and be prepared for the test and for the final exam, because these right triangles, sometimes you'll be given a problem that they don't necessarily tell you what the sides are or the interior angles. You just need to remember that for a 45, 45, 90, that these are the sides and these are the interior angles. For a 30, 60, 90, these are the sides and interior angles. And for a 3, 4, 5, these are the sides and the interior angles. And we'll cover each of these specifically. And if you have them written down on your note card and prepared for your test and final exam, you won't need to memorize any of this. Okay, so let's go ahead and look at our first special right triangle, and we're going to look at a 45, 45, 90. And I'm going to give you a brief breakdown of where the numbers came from, so that maybe you're a little bit more comfortable in using these. So to look at a 45, 45, 90, one of the things I want you to look at is look at if we have a side of 1 and another side of 1, so let's call that A and B. But C we're looking for, and I know that they've already given you the answer there in square root of 2, but let's just say, for the sake of argument, that we're going to figure this out from scratch using the Pythagorean theorem. And 1 squared plus 1 squared is 2. And we still have to find the square root because we need to get C by itself. And when we do that, we get C equals the square root of 2, which is what the hypotenuse is over here. And so just remember that that's really not that big of a deal. It means that we have side 1, this length is 1, this length is 1, and then this length is about 1.414 when you do the square root of 2. And that's right, because if you got a side of 1 and a side of 1, the hypotenuse is a little bit longer than both those sides, and it always will be. So that's where the measures came from on a 45, 45, 90 triangle. Now, here's some of the rules that I was talking about, and I encourage you to write these down. And maybe instead of a note card, maybe I will go ahead and have it to where it shifts to an 8x10 sheet of paper that you guys can write front and back for your test, so that you have an opportunity to be able to get all this without having to write it in like 4 or 6 Microsoft Word font. So, at least that size. So I want to have it to where this is useful to you. So I'm going to have the word help extracted from these on the slides so that you can see specifically how to use these rules or for the problems that you're using. So looking at a 45, 45, 90 triangle, when you are given the length of a leg, you'll multiply by the square root of 2 to find the length of the hypotenuse. So you're given a leg. So this is going to be the key on all these. What are you given? For the next one is when you're given the length of the hypotenuse, then you're going to divide by square root of 2 to find the length of each leg. Let's look and see what this looks like in practice. And we'll do this with all the special right triangles. So the problem wants you to find the length of DE and the line DE and AE. And so let's just go ahead and make sure that we can identify what these are. So DE is going to be that side right there. And then they also want you to find AE. And what they give you is AD. Well, AD says it is 2. So going back to the rules, if you'd like to pause the video here and go back and look at the rule and see if I'm given AD, which is a side, what do I do? Okay, so we're back. Hopefully you've gone back to your rule and you've seen that when you're given the length of a leg, in this case you're given the length 2, then you multiply by the square root of 2 to find the hypotenuse, and so you end up with 2 square root of 2 as the answer for this problem right here. 2 square root of 2, and you know that this side over here, side DE, in answering that question is 2 because it wanted you to find DE and AE. Because it's a 45, 45, 90, the sides are both the same, and so in being able to find AD, DE is the same as AD. All right, let's look at the next one. So similar as well. So go ahead and pause the video and try this one on your own. Okay, looking at the rules and understanding what they're looking for, they want you to find AB, which is a side, and they want you to find BC, which is a side, and they give you that AC is 5 inches. All right, so hopefully you went right to the rule because you can identify this as a 45, 45, 90. You have a 45-degree angle, a 90-degree angle, which means that the other angle is going to be 45 degrees. And so looking at the rule, we're going to use the rule that when you're given the length of the hypotenuse, which is what you're given here, 5 inches, then you divide by the square root of 2 to find each leg. And so in this case, we are given 5, and we're going to divide by the square root of 2. And remember, we said that the square root of 2 was about 1.414, so 5 divided by 1.414. And maybe what I should do is just go ahead and make sure that everybody understands what I'm doing. So 2, so there is the square root of 2 is 1.414. And so to solve this problem, we want to go 5 divided by 1.414, and that equals 3.47. 0.47, and that was given in inches. And so let's go back and look at this as we apply this to our sides. And does that make sense? We have a hypotenuse of 5 inches, and so our sides being 3.47 inches, which is less than the hypotenuse and equal to each other, makes sense. All right. Looking at the next type of special triangle, special right triangle, we're going to look at what they call a 30, 60, 90. triangle. And with this triangle, again, let's look at the root of where they come up with some of these numbers. When we look at the side, if we see that this side has a side of 1, and we'll call this side B, and this side has a length of 2. Well, that's our hypotenuse, we know that, and so we'll call that C. And then down here, this has a side of square root of 3, and that is A. So that whole square root of 3. Remember, it's a number, and it's a number that we can calculate. Now let's figure out how they got that square root of 3 being that number. And so going back and looking at the Pythagorean theorem and plugging in those numbers, we can see that if we're looking for A, so let's pretend we don't know that A is a square root of 3, but we're given the value of 1 for B, and we're given the value of 2 for C. Then when we square those, then we get square root of 1 is 1, square root of 2 is 4, and we subtract 1 off of each side, and we get A squared equals 3. We want to be able to get both of these by themselves, so we see that A equals the square root of 3. And just remember that really all that is that A is the square root of 3 is about 1.73 of the value, and so whatever the units are that they've got applied to it. Now, in doing this, this will help you then in understanding, hopefully, that whatever number you put in here, so say for this x right here, say we say x equals 5. Well, now we know that if x equals 5, and in this case we called it b before, the side b at least, side b equals 5, then that means that the hypotenuse is twice that of x, so we know that's going to be 10, and then we can substitute in here that instead of x, that for the other side, it's, because x is a value of 5, it's 5 square root of 3. And so that is a really simple way to be able to apply the values to this special right triangle of 30, 60, 90. But instead of trying to remember all of that, we have some rules that we can look at. And so again, I would highly recommend writing these down. I know it's long, but it's going to certainly help you out. And we'll go over each of these individual help statements as we go through the videos on each different type of problem. And so some of these you will be given the length of a shorter leg, and so remember on the video that's going to be opposite of the 30-degree angle. Some of these you'll be given the length of the hypotenuse, which we remember that's opposite of the 90-degree angle. And some of these will be given the length of the longer leg, which is the side that's opposite the 60-degree angle. And so remember that as you have your triangles in front of you and we go through these problems, and rewind this if you need to be able to look at it to indicate and identify which lengths go which angles. But I think this will be pretty easy as we walk through it. We're going to look at this one first, and we're going to look at the problem. It says, if this, or with this right triangle, and so importantly, make sure we're always remembering that we're working with right triangles for these rules, and we have a 60-degree angle called A, and B is 8 feet, then what are A and C? And so what we need, and that's little a and little c. What are little a, and little c? So let's identify what we have, and go ahead and draw on here. So it says B is 8 feet. All right. We know then that if B is 8 feet, that is our shorter length, not just because we can see that it looks shorter, but also because it's opposite our 30-degree angle. So with that information, I want you to pause the video and go to your rules, and what does it say about if you are given the length of the shorter leg? Okay, hopefully you went to the rules and you saw that when you are given the length of the shorter leg, then you're going to multiply it by 2 to get the length of the hypotenuse. And so to be able to get the hypotenuse, which is C, we will say that we will take the length of the leg, of the shorter leg, and multiply it by 2. So 8 times 2 equals 16 feet, and that equals C. Now, we still need to find A, which is this side over here, and that's our longer leg. And it says that when given the length of the shorter leg, then to get the length of, then you multiply it by 3, or the square root of 3, to get the length of the longer leg. And so what we'll do is we will multiply 8 times the square root of 3. And again, remember that was about 1.73. So 8 times 1.73. And that gets us 13.84 feet. And so looking at that, let's make sure that that makes sense when we go to apply these. And so if C was 16 feet and A is 13.84 feet, then our hypotenuse is longer than either one of our sides, which makes sense, and that's the way to be able to find that problem. So remember, take what you're given and follow the rules that are in the for that particular type of special right triangle. Let's look at the next one, and I want you to go ahead and try this one on your own and pause the video. Okay, so let's take a look at this, and we are given that we have a that big A is 60 degrees, and we can see in the triangle that it's a 30, 60, 90 special right triangle, and that C is 24 inches. And so C is 24 inches. Then that means that that is our hypotenuse, and we've gone ahead and identified that. And so let's go ahead then and look and see what the special rule is, because what are we given? We're given the hypotenuse. So if you haven't gotten it yet, go ahead and go back and look at what's the rule for 30, 60, 90 if you're given the length of the hypotenuse. Okay, so when given the length of the hypotenuse, then the instructions are to be able to get to the shorter leg, and in this case this is B because it's opposite of 30 degrees. So divide it by 2 to be able to get the shorter length. And so we have 24 inches, and this is for B. 24 inches divided by 2. And so that means that our shorter length will be 12 inches. And then it says to be able to get A, and make sure you pay attention here on this one, to be able to get A, you multiply this result, which is 12 inches in this case, by the square root of 3 to get the longer leg. So follow the instructions of what it says, and so to be able to get A, we multiply this result, which was 12, times the square root of 3. And remember the square root of 3. Let me go back and we'll just do it right on here so that you can see that it's not magic. And so we'll go ahead and get the square root of 3. And I would just have this written down on your page as 1.73. And so that's 12 times 1.73. That way you don't have to recalculate it every time. And you get 20.78 inches. So let's look and see and put this up here. Does that make sense? So it is our longer leg. It's longer than 12 inches. And it's shorter than the hypotenuse, which is 24 inches. And remember, both legs will always be shorter than the hypotenuse. So, yep, that is correct. And it follows the rules. All right, let's look at this one. Uh-oh, they don't give you a drawing. So read the problem, try to figure it out on your own, and then we'll figure it out together. Okay, so looking at this, what I want to do is I want to draw a picture, because I really work with pictures well. So given a right triangle ABC, A is 60 degrees, and there's a longer leg. So to me that says, okay, so I have a right triangle. A is 60 degrees, and so I know that that is 60 degrees is going to be the opposite of the longer leg, so this must be 60 degrees. So that must mean that this is A, because that's 60 degrees, and the longer leg, little a, is 32 yards. Okay. And so now we can just say A, this is A, B, C, and doesn't really say which the other ones are, but we can see that C is opposite. If this is a right triangle, which it says right triangle, that this is a 90 degrees, so that's 60, 90, so that means that's got to be 30, right? Because that's the difference of 180 degrees for the inside angles of a triangle. And so we've got, so let's see what we're given here. We have a longer leg of A is 32 yards. All right, so if we're given a longer leg and we have decided that we have a 30, 60, 90 triangle, then how can we find the shorter? So we'll call this C, excuse me, we'll call this, let's do this. I'm going to rename these again. Go up here, A, B, C. So we're going to call this shorter B and the longer section and the hypotenuse C. So we need to find B and C. And so how do we do that? Using our rules. And it says that we're given the longer leg. So when given the length of the longer leg, divide it by square root of 3. So when given the length of the longer leg, divide it by square root of 3 to get the length of the shorter leg. And so we're going for the shorter leg. And so B divided, we're given 32 by square root of 3. And that's going to give us the length of the shorter leg. And again, we had said that the square root of 3 was 1.73. We don't need to continue recalculating that. But what we can do is, and need to do, is figure out what that length is. So we can get the length here. And so that's 32 divided by 1.73. And we have 18.497, or rounded up to 5, and that is yards. And so this will be 18.5 yards. And now let's find C. And so looking at the rule, it says for C, Then multiply this result by 2 to get the length of the hypotenuse. And so we'll take this result, which was 18.5, and we'll multiply that times 2. So C equals 18.5 times 2, and that will be 37 yards. And so that says this is 37 yards. And let's look at this. Does it look correct? If we have the shorter leg is 18.5 yards, the longer leg is 32 yards. Yep, that's longer than the shorter leg. And the hypotenuse is 37 yards, which is longer than both the legs. Then, yep, that looks like that's correct. And so there you go. And it follows the rules. All right, we're going to look at one last triangle. This is a special triangle of 3, 4, 5. I've mentioned it before. This is probably my favorite special triangle because I use this in construction. Matter of fact, I will be teaching a lesson on that using this this Saturday for a framing floors class that we're doing. And so the 3, 4, 5 is a really useful special right angle in carpentry. And so let's just go ahead and look at how this is used. It's pretty simple. It's all in multiples of 3, 4, and 5. And so you can have, as you measure out 3 feet in one direction, and you measure out in 4 feet in another direction, then you know that when you pull your tape for your floor, that this will be 5 feet or in multiples thereof. Okay. So let's look at this triangle and go, okay, well, if you don't recognize this triangle immediately as a special triangle, it's okay, because the one thing I want you to get used to is I want you to get used to the fact that with any right triangle, if you are given at least one of the two sides and the hypotenuse, or the two sides and not the hypotenuse, that you can figure this out going back to, wait for it, what's the theorem that we use? Yep, that's right, the Pythagorean theorem. And so what we'll do is we will just say a squared plus b squared equals c squared, and we'll substitute in, we don't know a, c squared, or excuse me, b squared is 6 squared, and c squared is 100 squared, and so we'll go a plus 36 equals 100. Get a by itself. And so this is, bring down a squared equals 64. We want to get that a by itself and not under an exponent. 64, the square root of 64 is 8 times 8, and so a equals 8. And in this case, you can see that this is a special triangle as a multiple of the 3, 4, 5. So 3 times 2 is 6, 4 times 2 is 8, and 5 times 2 is 10. But you really don't need to know those to be able to solve this problem. If you see a triangle and it's a right triangle and you can solve it using the Pythagorean theorem, go for it. All right, let's look and see how we can solve this problem right here. And so if you feel comfortable and you want to take on the challenge, go ahead and pause the video. We'll work through this stepwise, and you'll have a couple opportunities to pause the video as we go through. So if you don't know where to start right now, hang with me and we'll figure it out. Okay, if you've gone on and looked at this, there's a couple things I really want you to make sure to identify when you read the problem. This is talking about where a cut is to be made in a rectangular piece of sheet metal, and we are looking to be able to find X. And so X is over here, but the cut that they're talking about is the triangle that's over here. And so, and when I say over here, let me draw that, is over here. Now, one of the things that's important as we're looking at this and trying to figure it out, we need to identify what we're given. One of the things that we're given, and I hope this pops out immediately, is the type of special triangle. This is a special triangle. It's a 30, 60, 90 triangle. And so that means you're going to flip over to your 30, 60, 90 rules when you're trying to figure this out. So if that was something that as you're trying to figure this problem out, you're like, I don't know where to start, maybe start there. And you can pause the video and figure it out from here. Okay. Another thing that we need to look at, that we need to be given, that we can't solve this problem quite yet because we don't have any values that we're given. So in a 30, 60, 90, we need to at least be given the value of the length of the short side, long side, or hypotenuse. And so let's figure out then which of these values we can get. We can't get the short side because we can see that it's 18 is the length up here, but we don't know what x is, so we can't get the difference. But we do see on the sides that this is 28 inches on this side and this is 12 inches here. So the difference of that means that this is 16 inches. Now that we have the length of a side, and this is the longer side, we can go ahead and solve this problem. Go and look at your rules and see which rule you would use. Okay, so with the rule, what we're going to do is we say the rule is when given the length of the longer leg, we're going to divide it by the square root of 3 to get the length of the shorter leg. And so we're going to divide it by 3 to get the length of the shorter leg. So the length of the longer leg is 16, and we're going to divide it by 3. And with the taking the square root of 3, we know that that is 16 divided by 1.73. And let's go ahead and do the math, get our calculator here. And we end up with 9.25. And so that is going to be this value right here. That is the value of our shorter leg, 9.25 inches. And is that what the problem was looking for? Let's see. The problem was looking for, suppose we need to find, we need to find the length x. And so that's this value right here. So to be able to find the value of x, now all we need to do is just take and subtract from our value up here. We know that this side up here is 18 minus 9.25, and given that, we can say that x, after we do the subtraction, is 8.75 inches long. And that answers the question that they're looking for right there. Okay. And one final problem. We're going to look at the cathedral ceiling. This is something that that I can face on a job site, and you may face if you're doing a project at home or on a job site. Maybe you're using it for any number of applications. So you need to find the length of a beam along the top of a wall. And so we're given this figure. So go ahead and pause the video if you want to try to solve this one on your own. Okay, so let's look at this and let's solve this problem. One of the couple things that we know is, since it is a trapezoid, that it has two parallel lines, and we know that because both of these are at 90 degrees, and so that makes them parallel to each other. And if those are parallel, that means that I can draw a perpendicular line across here, and it's not very straight across, but I'm going to put this right here so that you know that's a 90 degree, because if this is a perpendicular line and it's 90 degrees to this, then I know that if this wall is 8 feet and this wall is 12 feet, that for the whole wall, that this is going to be 4 feet for this section and 8 feet for this section, because the ceiling is level there. So given that, do I have enough to be able to solve the problem? Well, let's see. First off, because I'm doing special right triangles, is this a special right triangle? I don't think so. It's not a 30, 60, 90. It's not a 45, 45, 90. I don't know if it's a 3, 4, 5. No really special rules with that. But what I do know is that I have the value of the length here of the leg, and I have the value of this leg, and I'm looking for the hypotenuse. And I know then that if I go a squared plus b squared equals c squared, that I can plug these values in. Go 22 squared plus 4 squared equals c squared, or in this case they're using the value y, but we'll go ahead and substitute that in. Let's get our calculator. And we'll say 22 squared is 484. Plus 16, which is 4 squared, equals c squared. 484 plus 16 is going to be 500 equals c squared. Square root of both sides, and the square root of 500 is 22.36. I believe that was in feet. Yep. And so let's go ahead and look at this then. And so 22.36 feet. Just do a mental math check that the hypotenuse is longer than any other value of the sides, and it is not much longer than the 22 feet ceiling, but that's okay because we're only carrying it out just a little bit. We're only carrying it up 4 feet. So that is the answer to that, and that concludes this set of videos, or this video.